Hey guys, this is Mr. C, and in this video we're going to be talking about relations and functions. So, a relation is defined as a set of ordered pairs. That is your definition for a relation, a set of ordered pairs. So make sure you remember that. And here's an example of a set of ordered pairs. And so we have 1, 2, 3, 4 ordered pairs, and that is the definition of a relation. They're going to be represented in other ways, but that is one way to represent a relation, a set of ordered pairs by definition. The first numbers in our sets of ordered pairs, -1, 3, 4, -1, we call those the domain, and we usually write those as a set of numbers in curly brackets. So the first numbers are the domain, and then we have the second numbers, -4, 2, 6, and 8 are all going to be what we call our range. So we have domain, and then range is the second numbers in our sets of ordered pairs. So there's a couple ways that you can show a relation. One of them is with what's called a mapping diagram. And a mapping diagram is just another way to represent a set of ordered pairs. And so you have the x and f of x over here. We can also call those the y values in our ordered pairs. And so remember, in our ordered pair, it goes x comma y, just like in previous years. So we have some ordered pairs going on. We have 1, 2, 2 comma 3, 3 comma 2, and 4 comma 1. And that is a mapping diagram that also can be used in place of a set of ordered pairs. We have our domain on the left, and we have our range of the ordered pairs on the right. Again, those are our y values. We can always write y. F of x is function notation, and we'll get into that later in the course in Algebra 1. Here's our ordered pairs, 1 comma 2, right there, 2 comma 3, right there, 3 comma 2, and 4 comma 1. Most teachers, if not all of them, are going to have the domain on the left and the range on the right, and these arrows show how they're matched up. The x values match up to the y values. And again, those are another way to say the y values. So a mapping diagram is sometimes a very visual way to show a set of ordered pairs, a relation. We also have a table of values. And so in our table of values, we've all seen those. We have our domain on the left, the x values, our range on the right. Those are our y values. And so no problems there. We also have our ordered pairs. And so we have 1 comma 6, 3 comma 10, and -2 comma 0. So we do see that this is a relation because it is a set of ordered pairs. It's just shown to you as a table instead of a graph, or I'm sorry, instead of a set of ordered pairs. So in curly brackets. So another very useful way of writing a relation. Now sometimes we're going to have relations that have a lot of ordered pairs. This graph right here, this is called a parabola. And so that parabola right there has a lot of ordered pairs that you can't write them all down because there's so many. So what we do is we graph that thing and we show the behavior of this function and the shape of it. And we can get some ordered pairs from there, like these or these. But we definitely can't get all of them because we don't know what these are inside here from here to here. We do know that that ordered pair would be -1, 1. And we do know that this ordered pair right there is 1 comma 1, but a lot of the other ones we have no idea. So we have this graph right there to show us the shape of that and the behavior and how it's going to work as it gets wider for the x's and then for the y values as it goes that way. Now we also have the domain and the range for these things. So the domain for this graph, and the copier kind of messes up my variables here sometimes, so we'll have to deal with that. So the domain is all the x value, all the values that x can have. So for this graph, if I look at my x values for this whole thing, every single x value has a y value with it. It's going to keep on going this way forever because this is going up and over all the way to infinity and all the way back to -infinity. As x gets smaller, you're always going to have a y value associated with it. So we say that the domain for this particular one is all real numbers. And so this right here just means all numbers x such that x is a real number for the domain. So it also has a range too, and they always want you to find the domain and range. So here's our range, and our range here are just the y values. Now, we do have y values up here, right? Got all these y values for all these ordered pairs. As a matter of fact, most of these have 2 of them associated with it. But we have nothing down here, all right? It starts at 0 and the range goes up, but definitely not down because there's no graph down here. It's all right there. So this range would be all y such that y is greater than or equal to 0. So all the y values are up here and none of them are down here. And that'll take some getting used to with the domain and range. You can also have a relation that's given to you as an equation. 3x plus 4y equals 12 is definitely an equation. It's the equation of a line. And you also have this one down here. It's this quadratic equation. We'll deal with that later in the course. Y is equal to 2x squared minus x plus 1. Again, it prints my variables out weird, but that's just how the copier does it. But those are definitely an equation. It's definitely a relation also. It defines a relation. So now we have the idea of a function. A function is a relation in which each value in the domain is paired with exactly one value in the range. So here's what that means. You can't have, for a function, you can't have an x value repeat itself in the order of pairs. You can't do it. If an x value repeats itself, it means you have an x value matched up with more than one y value, and it's not going to be a function. And that's the definition of what a function is. All the x values have to be different, and the y values can repeat, but the x values all have to be different in the sets of ordered pairs. So we're going to look at a bunch of examples for this. And so the main thing is, when you're looking at to see if something is a function or not, you only look at the x values, all right? You don't look at the y values, only the x values. So here we go. Okay, so is this one a function? So let's take a look. We got 12, 9, 10, and 15. You ignore that, ignore the y values. They're of no use. Are these all different? Yes, they are. So the answer is yes, it is a function. All right, let's try this one. Okay, so again, we have -1. Let's mark through the y's. 3, 4, and -1. So do any of the x values repeat? It looks like these do. And so since these repeat, it is not a function. Is it a relation? Yes, it's a relation, but it is not a function, and so I have to just say not a function. And in math, most of the time we like functions because functions behave very well. And relations are okay, but functions are preferred. So that one's not. Let's take a look at this one. So when you have one like this, a mapping diagram, you look to see if there's one arrow coming out of each of the x values, only one. And so what you do is you don't look at any of this. Ignore that. Do we have one arrow coming out of each of these values here? So one arrow, 1, 1, 1. If that's true, then it is a function. All right, so let's try this one. Do we have one arrow coming out of each of the x values? Well, let's look at it. Let's get rid of all this. Okay, got 1, there's 2. So that kills it immediately. So that is going to be not a function. And so again, we look only at the x values, we ignore the y values, cover them up so you can't see them. And so for these mapping diagrams, you only look at these arrows and you only look at the x values to determine if something is a function or not, for relation as a function. All right, let's take a look at this one. We have a table now, and so is that table a function? Well, let's look at all the x values. So again, we're ignoring all those. 0, -8, 2, 1. Those are all different. So yes, that would be a function. Okay, now we have this one. Is that a function? So we look again at only the x values. 3, -6, 4, got another -6. That's not a function. Okay, this one now, a graph. In order for it to be a function, it has to pass what we call the vertical line test. So what you do is you take a ruler or a pencil or something like that, and you go bottom to top, and we're going to start right here where the graph starts, right there. And as you see, as I keep going up, there's one place where it touches right there, my ruler. But as soon as I go up, there's two places, here and here. That's bad. That's good. Here and here. Okay, so we're good there. But what we really need to be looking at is the vertical line. So let's move our ruler this way, because if we look this way, we're not really looking at the x values. So let's look this way instead. So if we look this way, okay, we'll start here, we're good. You keep going, one place, one, and so on. So if I pass the ruler across this way, that's called the vertical line test. And it only hits the graph at one place all the way through. Now, I previously started like this, didn't I? And students do this all the time. This is called the horizontal line test, and this is really for something completely different right here. So I don't want to do the horizontal line test, I want to do the vertical line test every time like this, all right? So let's make sure that we do the vertical line test on every one of these. Okay, so again, I don't want to do horizontal yet, I want to do vertical. So if I do vertical line test here, all the way across, and it starts right there. But as soon as I move over, two places, and again. And so every time it hits those two places, that is not a function because it fails the vertical line test. Okay? And so since it fails the vertical line test, because you get two there and two here and all the way across, the only place you get one is right there. Because it fails it, it is not a function. So we just need to be careful with that. All right, so now what we're going to do is we're going to take a look at a bunch of examples, and we're going to see if they are functions or not. So here's our first one. So is that a function? And so as you're looking at it, I'll give you a chance to take a look. All right. So we got -2, 4, 5, and -2 for our x values. Only the x values. Is it a function? I say no, not a function. And why not? -2, -2. I don't care about the y values. I'm only looking at the x values. And these two repeat. Can't have that for a function. Okay, what about that one? Is that one a function? Take a look at it. Okay, so if I'm looking at it, again, I'm looking at the x values, 7, 8, 8, 7. I'm seeing problems here, and I'm seeing problems here. I got 2 7s and 2 8s. Not. That one's definitely not a function. Let's try this one. Is this one a function? I got 15, 10, 12, and 12. Well, these two 12s, those are going to be a problem, aren't they? So this one is not a function. Let's try this one, see if this one's any better. Okay, so take a look at that. 8, 7, -7, -8. Well, these are different, and these are different. 8, 7, -7, -8. Those are all different numbers. So this would be yes. That one is a function. What about the mapping diagram? Okay, so you remember for a mapping diagram, you have to look at the arrows coming out of the x's, right? You ignore everything else like this. One arrow, one arrow, one arrow. So this would be a yes. Okay, so what about this one? That one's a mess, isn't it? There's arrows all over the place. Well, let's cover all that up. I don't want to look at it. 1, 1, 1, 2. That's 2 arrows right there. That is not a function. Okay, what about this one? Do we have 1 arrow coming out of each of the x values? So if I go ahead and I cover those up, I got 1, 1, 1, and 1. So that would be a yes. That would be a function for that. And what about this table of values? Take a look at it. All the x values have to be different. But I see this. I see a 2 and another 2. That's a problem. So that would be not a function. Okay, so what about this table of values? 0, 1, 2, 3, 4, those are all different. So we'll take that one as a yes. Okay, that one looks pretty good. All right, so let's get our graphs again. So what kind of a line are we going to look at for these? Are we going to look at a horizontal line or a vertical line? We're going to look at what's called the VLT, the vertical line test, which means I need a vertical line, not a horizontal one. Okay, we're going to pass the vertical line across. So here is my graph. This, let me make it a little bit, you can't really see that very well, but I'm trying to make it bluer. I guess I can't. Okay, so I'm not counting the axes, can't count those. So I'm hitting it one place, 1, 1, 1, all the way across, good. Okay, all the way across, one place, and that's it. So it passes the vertical line test, so I would say, yes, that is a function. All right, so what about this one? Is this one going to pass or is it going to fail the vertical line test? So let's take a look. What do you think? Okay, so I'm gonna pass my vertical line test, my vertical line across. Remember, that's just an axis. We don't count that. We only count this guy. So right there, we get one place where it crosses, where it touches my ruler. But right after that, 2 places every single time. So since that happens, that fails the vertical line test, and that is not a function. You're gonna get all kinds of these, like this one. That's just a weird looking relation. It is a relation, it's just kind of weird looking. So let's try this one out. So we're going across, we're good here, we're good. And then right there, it touches the ruler there and there. That's enough to kill it right there. If we keep going, we can actually find a place where it touches 3 times, which is even worse. Not that it matters because it still is not a function. And as we go across, we see places where it still happens. And even though we clear it right there, just one place, all that stuff in the middle counts. And so this one would not be a function. Now here's a good one. This is a vertical line. Do you think that this passes or fails the vertical line test? Well, let me show you something. If you pass your vertical line across, is this going to pass or fail? Going across, and boom. The whole thing is a vertical line. And so by the very definition of a vertical line, it's going to fail the vertical line test because it is a vertical line. This is actually the worst case scenario you can have. This is definitely not going to be a function. It is not. Be careful with those because students will get those confused a lot of times. All right, let's try this one. Do you think this one's going to be a function? All right, let's pass our vertical line across and see. So we're good here. 1, 1, all the way across, good. It hits it at one place, hits the ruler at one place, good, and done. Arrow to arrow. So only one place all the way across, and the answer is yes. That will be a function. Okay, so what do you think about this one? That one looks a little bit different. Let's try a vertical line test. So I hit an arrow, one place, 1 all the way up, and 1 all the way across, and it works all the way from arrow to arrow. So that'd be a yes. That is a function. Okay, so take a look at that one. Okay, so let's use our vertical line test. So right there, we start at the arrow. So one place, all the way across, 1, 1, good still, all the way, 1, 1, and arrow. So it passes the vertical line test all the way across, and it is a function. Very important to understand the concept of a function, because it's going to be in every class you take from here on out. All right, guys, remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.